Alright, this is our final lesson on absolute values. It's solving absolute value equations. And let's have a look at our first warm-up here. We've got x squared equals 9. So we'll square root both sides. The square root of x squared is the absolute value of x. That equals 3. And we've been working with absolute values long enough that we should be able to see that x can either be plus or minus 3 from that. And just quickly verify our solutions. 3 squared equals 9 is true, and negative 3 squared equals 9 is true. Okay, next one. Absolute value of 3. Well, we just did that, didn't we? So x either has to be plus or minus 3. And again, let's verify our solutions. Absolute value of 3 equals 3. And the absolute value of negative 3 also equals 3. Good. Alrighty. X plus 2 squared equals 25. Same thing, square root both sides. And again, that's going to give us the absolute value of x plus 2 is going to equal 5, which means that either x plus 2 is going to equal 5, or x plus 2 is going to equal negative 5. Subtract 2 from both sides. X is going to equal 3, or subtract 2 from both sides. X is going to equal negative 7. Quick check those. Oops. That's not negative. It's a positive 3 plus 2 squared equals 25. That gives us 5 squared equals 25, which is right. And negative 7 plus 2 squared equals 25. That gives us negative 5 squared equals 25. Also true. Alright, number 4. Find all values of x that make that equation true. That's what it means to solve. Okay, so let's go about solving this guy. So, same as above, if x minus 3 equals 4, then x minus 3 is going to have to equal 4, or x minus 3 is going to have to equal negative 4. Add 3 to both sides, x is going to equal 7, or add 3 to both sides, x is going to equal negative 1. Notice at the bottom there, it says that we may have extraneous possible solutions. So that means that when we get this stuff, it may not make the original true and therefore won't be a solution. So let's just make sure that these two are actually solutions. 7 minus 3 equals 4. So we get the absolute value of 4 equals 4. That's true. And this one we get the absolute value of negative 4 equals 4, which is also true. Alrighty, next question, exact same thing. So x minus 4 is either going to equal negative 2x, or x minus 4 is going to equal negative 2x. So this guy actually, let's not do that. Let's get our x's on the right. So let's subtract x from both sides. So I have negative 4 equals negative 3x. Divide by negative 3. Get x equals, positive 4 over 3. Or over here, we get x minus 4 equals 2x. Subtract x from both sides. And I get negative 4 equals x. Okay, let's make sure that both of these work. So let's try this guy first. Absolute value of 4 over 3 minus 4 is going to equal negative 2 times 4 over 3. Notice that whatever comes out of the absolute value is going to be positive, and the right side is negative, so those will never be equal. So this is not a solution. That was an extraneous possible solution we had to throw out. And let's try negative 4 now. So absolute value of negative 4 minus 4 equals negative 2 times negative 4. So the absolute value of negative 8 equals negative times negative is a positive. Positive 8, that one's good. Notice the textbook has a different way of finding these extraneous possible solutions. They use more of a piecewise method. If you want to do that, feel free, as long as you show me that this is the only solution, I'm happy. Okay, let's have a look at number 7. Basically, we can think of this absolute value sign the same as we would if it was a square or a root. Let's get it by itself before we do anything. So let's divide both sides by 2. That gives us the absolute value of 3x plus 1 equals x minus 4. And now we can break it into two possibilities. Either 3x plus 1 is going to equal x minus 4, or 3x plus 1 is going to equal negative x minus 4. Okay, this guy, let's get the x's on the left. So subtract x from both sides and subtract 1 from both sides. So we get 2x equals negative 5. So x equals negative 5 over 2 is one possibility. And this guy, let's simplify first. X is on the left. And subtract 1 there. So we get 4x equals 3. Alright, let's verify our solutions. So the absolute value of, 2 times the absolute value of 3 times negative 5 over 2. Remember to always verify your solutions in the original, never a rearranged form. Okay, and again, notice the right side here is going to be negative. We've got a negative minus a negative. The left side is going to be positive because it's going to be, this is positive, 2 is positive. So there's no way the left side can equal the right side. So that is not a solution. Okay, let's try 3/4. Oops, that's not a bracket, that's an absolute value. So that gives us 2 times the absolute value of 9 over 4, plus, let's get a common denominator, 4 over 4, equals 6 over 4, minus 32 over 4. And notice that is also going to be negative. So, no good. Actually, I guess there's no reason to X that out. So neither of those possible solutions will make our original true, so we have no solution. There are no values of x that will make that equation true. Here's our last question from the textbook. As usual, not very much different, just uglier. So we've already got the absolute value by itself. So we know that 4x plus 6 is either going to equal x plus 8, or 4x plus 6 is going to equal negative 8 plus, or sorry, x plus 8. Notice that if you feel more comfortable with the absolute value on the left, you can switch it, right? 2 plus 3 equals 5 is exactly the same as 5 equals 2 plus 3. Right, so if you want to switcheroo them, go for it. Alright, so let's get our x's on the right. Subtract x from both sides, and that means the numbers will be on the left, so subtract 6 from both sides. So we get 2 equals 3x. X equals 2/3. Okay, so we've got to multiply this negative through first. So that goes, so we end up with negative x minus 8 equals 4x plus 6. Let's get the x's on the right, which means we'll put the numbers on the left. So our two possible solutions are x equals 2/3 or x equals negative 14 over 5. Alright, let's see whether or not 2/3 makes our original equation true. So we get 2/3 plus 8. So common denominators, 2/3 plus 24 over 3. And that's going to be 8 over 3 plus 18 over 3. So we get 26 over 3 equals the absolute value of 26 over 3, which is true. Good. Alright, so this is one of our solutions. It makes the original equation true. It's a solution. Okay, let's try our next one. Okay, and common denominator 5 this time. Oops, that's not equals. So we get 26 over 5 equals the absolute value of negative 26 over 5. Also true. So in this case we have two solutions. X can equal 2/3 or x can equal negative 14 over 5, and both of those will make the original equation true. Okay, so a quick recap. You want to break your absolute value equation into two possibilities. When you get your solutions, make sure you verify them because they may or may not make your original true. If they don't make your original true, they're not a solution. Throw them away.